All right, my friends, let's see how it went. So we need our new vector to be equivalent to vector AB. So there are a couple different ways to do this. Personally, I just imagine that I'm shifting this vector so that instead of having it start at, 2, 4, it's going to start at 0, 0. So if I did that, then I would take the initial point and I would kind of pick it up and move it to the left 2 and down 4. And then I hope it makes sense that I would need to do that to the terminal point as well. So I would take the 0.58 and I would move it to the left 2 units. So instead of an x-coordinate of 5, I'd have 3 now. And then I'd go down 4. So instead of 8, I'd be at 4. Anyway, and so there we go. So I'd have this new vector. So I'm actually going to erase that 2, 4. It's a little cluttery. So anyway, I'm sorry I cannot draw a straight segment today to save my life. I can't. Anyway, so there you go. Pretend these are straight. Okay. Hopefully you're doing better than I am. Okay, so some notation, my friends. I know that at the beginning I called this first vector vector AB. That's a way to do it. Another way would be to name the vector like with just a single letter, kind of like back in geometry. Sometimes we used a single lowercase letter to represent like a line. So you could have like, let's say this original vector, let's say I called it vector W. And let's say this new vector, let's say I wanted to call that vector V. So I'll just label which one's which. The next thing I want to talk with you about is something called component form, and I'm going to make this official when we start the next example. But for now, I'll just say it in words. Component form of a vector gives you the coordinates of the terminal point, and you are to assume that the initial point is at the origin. So for vector V here, its initial point is at the origin. And so the terminal point right here, what would the terminal point be for vector V if you took 5, 8 and shifted it to the left 2 and down 4? So I claim that the coordinates of that point right there would be 3, 4, like that. And so we would actually say that the component form of vector V is 3, 4, okay? So what I'm going to do is come over here and add that in. So let's say we call this vector V, this one that we shifted to start at 0, 0. Component form has these fun brackets like this, and that's how you can tell that you're supposed to assume that it got shifted so that its initial point would be at 0, 0. And then all you have to do is put the coordinates of the terminal point in there. And simply because you used these fun little brackets, everybody in this world is supposed to know that you meant that it got shifted, so it starts at 0, 0. So there you go. So here's component form of this vector that we have there. Okay. All right, my friends, let's go on to example 2. Okay, so first let's start with a definition and then we'll actually get to the question. So let's make this component form deal official. So component form of a vector gives you the coordinates of the terminal point. And you are to assume, when we're using this notation, that is, you're to assume that the initial point is the origin. Okay, so now that we've got that, let's give you part A here. I'm going to ask you to graph each vector. Let's say I tell you vector U has component form 3, negative 2, and vector V has component form negative 1, 5. And how do we know it's component form? because of the brackets. All right, my friends, go ahead and graph those. And then once you're done with that, see if you can figure out for part B, let's see, what vector u plus vector v would equal. All right, and if you have no idea, just guess. You'll probably guess right.